All right, so now we're going to get into our rules of differentiation. That is, you can call them shortcut rules if you want. We're not going to have to do that the long limit process anymore. That was kind of the intuition. Why is a derivative what it is? It's that slope of the secant line becomes the slope of the tangent line, which is how we define the derivative, and we had a formula for that, right? It was the change in, what is that? The change in y, which is my numerator, over the change in x, which we called h or delta x, as h goes to 0. Right? And we had to do derivatives that way, but now we'll have an easier way to do them. And if we want to establish all these, we would have to prove them. Here's my first one. This one's easy. It's constant rule. Derivative of a constant is 0. Now, if I wanted to prove this, I'm not going to do the proofs for each of these. They all come with a proof. Mathematically, we'd like to prove them. So each rule I give you, and we're going to have a bunch, we'd have to use the limit definition of derivative. But if my function is a constant function, this one's easy to prove. I would have to, for each one of these, I would have to say, okay, how is this true mathematically? The intuition's easy, right? Here's the intuition. Constant function is horizontal line, right? The slope of a constant function is one way we talk about derivative, slope 0. Or another way to think about derivative is how's the function changing as x changing? How does y change as x change for any particular x value? Well, it doesn't, right? It's constant. So that one's pretty easy. The proof of this one, let's do a proof. I would say, what's f of x plus h? What do you think? Well, it's c, right? Any input gives you a c as an output. So f of x plus h is c. F of x is c. So before I take the limit, I have this constant function to take the limit of. Okay, so that's a real simple proof. I did that one because it's short. But I won't do a lot of these. I'll show you, I'll post a video of the proof of one of the real, one that we'll use all the time that's actually for a function of x. Let's get to that one. So you'll see that a lot. How about the constant multiple rule? So this one I think is pretty straightforward, the intuition as well. That is, if I have, and we learned this in limits, if I have a constant times a function, when I take the derivative of that, it'll be the derivative of the function times the constant. We see the difference there. That is, I can just kind of like the constant kind of comes along for the ride. For example, well, I think we need more rules before we can do that one. How about this? Could we figure this one out? We don't really have a rule for x. Well, let me come back to that one because I think we need more rules we could do this with the limit definition, but I think we need more rules before we tackle these. And here is our first real rule of a varying function. Okay, it's called the power rule. So if n is non-negative integer, then the following is true. So non-negative integer. What's a non-negative integer? 1, 2, 3, and so on. This one's really useful. Let's apply it. So let's see, if I have some power function, if I want to take the derivative of x cubed with respect to x, what does this rule tell me to do? Well, bring down the n. X, take 1 away. That's it. Okay, now go back and look at some of those functions, or you'll still have to do functions by the limit process. So when you do that, you can check your work now. Because on test 1, I'm going to say, take the derivative of, I don't think I'd make you do a cubic, but take the derivative of like 2x squared minus x. This was kind of a typical problem I'd make you do by the limit process. Remember the limit process, and you do step, step, step. It'd take a lot of work. But now you can do it real easy. Oh, we can use our constant multiple rule. So that's the last rule. The 2 comes along for the ride. Now apply the power rule. 2x, take 1 away. And then how about the power rule for this one? Well, you're going to learn that linear functions we kind of already saw that that the derivative of a linear function is just the slope of that line, right? Because that's how it's changing. So that's just 1, but you can still apply the rule. You bring the 1 down, multiply by 1, and then you take 1 away, right? So that would be x to the 0, which of course is just 1. So the derivative of 2x squared minus 1x is 4x minus 1. Okay, so if I asked you to do this function by the limit process, you should get the same answer. It's just a lot more work. But now think about it. On test 1, I'm going to say, hey, take the derivative by the limit process, and I'll make you show your work. But then you can check your work by these shortcut rules, so you know if you're right or not. Okay, because this derivative is pretty easy using our new rule. Okay. Let's see. Before I move on, well, I guess I've actually already applied this one. This one's pretty self-explanatory. If you have a sum, I just did it without even giving you a rule because I think it's pretty simple that if you have the sum of two functions, then the derivative is the derivative of each one with the sum or difference in between. Okay, so these will all be official rules. Some of them are pretty simple. Some of them we need a formula for, like this power rule. And this one, I don't want to spend the time, if you're interested, and you probably are since you're calculus students, to take a look at the video that I provided that gives you the proof of this. Remember, if you want to do the proof, and I love doing these, so I'd like to do it, but I just don't want to make this video super long. So if f of x is x to the n, and I want the derivative, I want to establish that. If I need to do some real math for it, I'd have to do this, right? I'd have to say, okay, well, the derivative, I have to prove all these by our definition, and that's going to be f of x plus h, just like it always is, minus f of x over h. Okay, so take a look at that video. I think you'll find it interesting. It's, I don't know, maybe 8 minutes or so. Here's the complicated part. It's the algebra involved. It's not terrible. What do you do with that thing? Okay, what do you do with that? That's an expansion. We have the binomial expansion theorem you might have seen in algebra class, Pascal's triangle. And proofs are fun. I mean, you guys are math people. You're in a calculus class, so you probably want to take a look at this. The problems are easy. The proofs are a little complicated. Okay, but go ahead and take a look at that video, see if you can follow it. It establishes this rule. I'll do some proofs as we go along, but I won't do all of them. All right, so we probably need to do some examples here. So let's see. Let me give you a couple examples to do. When I write these down, let's see, 4x squared minus 3x plus 8. How about something like this? 7x to the 5th minus 4x to the 3rd plus 8x, all divided by, let's say, x. Okay, find the derivative. Those are the directions. Go ahead and pause the video, see if you can get them. So these are pretty constant multiple rule. I mean, once you do these, you don't have to really, you won't have to think about like what rule you're applying, and I won't make you write down what rule you're applying. I just want you to tell me the derivative. So you say, okay, well, constant multiple rule, power rule, 2x to the first. The linear function, so it's just the derivative is just the slope, or the power rule, 3. And then the derivative of 8 is 0. 8x minus 3. All right, this one, you're going to see this stuff a lot. Remember this. Do algebra before you do calculus. If you can simplify the function before you do any calculus step. Okay, that's important. We're going to learn a quotient rule, which is, as we go through these rules, they get a little more complicated. We're going to learn a rule how to take the derivative of a quotient, which is what I have here, right? Something divided by something. And then it's going to be a little more complicated. But if I can avoid that, then I want to avoid it. If I can simplify my function first, then that's what I want to do, right? G is equivalent to 7x to the 5th over x minus 4x cubed over x minus 8x over x. I guarantee I'll put something like this on the test because I want you to be looking out for ways to simplify before you do calculus, to use your algebra or trig before you do calculus, okay? So do that. It'll save you a lot of trouble. We don't want to do more work than we have to. We'll get to that quotient rule here in a little bit. I can do some algebra. And now, and also be careful with your labeling. This is G. This is G. This is important in a calculus class. We're always working with the function and the derivative. Function and derivative. So I want you to label what you're working with. G, G, G. We haven't done calculus yet. Now calculus. 28x cubed minus 8x to the first minus 0. That's it. Okay. Let's see. Before we jump into some more rules, let's talk about tangent lines and their equations. Now, we've talked a lot about the slope of the tangent line, but I want you to find, and maybe a little bit about the equation, find the equation of the tangent line. And let's just say at x equals 1. And then I give you a function. This is a real common problem in calculus because the tangent line is so important. So I'll give you a simple function. Let's say 2x squared plus 4. Okay, so find the equation of the tangent line. So what do we need for the answer for this function? Well, my answer is going to look like this. Y equals mx plus b. Right? That's the equation of a line. What do I need? I need the slope and I need the y-intercept. How do you find the slope? You do calculus. The slope of the function at x equals 1 is equivalent to the derivative of the function at x equals 1. We've talked about that before, but I can't stress how important it is. The slope of the tangent line at x equals 1 is equivalent to what? F prime of 1. Okay, so this m I get by doing calculus. So let's see. The slope of the tangent line, first I'll find the derivative, 4x plus 0, and then I'll find f prime of 1, which is 4 times 1, which is 4. Okay, important. The slope of the tangent line at x equals 1 is equivalent to f prime of 1. So now we have the slope. Y equals 4x plus b. How do I find b? Well, that's old algebra stuff. There's a couple ways to do this. You might have learned different ways. How I'll do it is I need to plug in x and y, and that allows me to find b. Okay, so what's x and y? Well, I only gave you x for the function itself. So actually I need y as well. It wasn't given. So what's y when x is 1? Oh, this is a good example when we go back and forth between function and derivative. I plugged in 1 to the derivative to find the slope of the tangent line there. I'm plugging in 1 now to my function because I just need the output. That's not a calculus thing. That's just where the y value is when I plug in 1. It wasn't given to me. So I could have done that first if I wanted to. So let's see. That would be 1 squared is 1 times 2 is 2 plus 4 is 6. Okay. So this is the point on the graph. If I were to graph this thing, 2x squared plus 4, I don't know, looks something like this. And then when x is 1, this should be the point 6. Input 1, output 6. And here's my tangent line that I'm trying to find the equation for. My graph is pretty bad, but it looks like it should be negative. Let's see what I get. So I plug in 6 equals 4 times 1, which is equal to b. So it's not negative. So let's see if I can figure out what I did wrong over there. It's probably just my poor graph. B should be 2. Subtract 4 from both sides and I get b equal to 2. Okay, so my answer to the question is the slope of the tangent line is y equals 4x plus 2. And that should be tangent at x equals 1 to the function 2x squared plus 4. So when I graph it, I'm going to go to the Desmos and graph this thing. And it should be tangent at x equals 1, and then I can see what's wrong with my rough sketch over here. I think I know what's wrong. It's just a bad sketch. So let's take a look at Desmos. Okay, so there's my quadratic, and then I'm going to check my answers. That's 2x squared plus 4. We found the equation of the tangent line to be 4x x plus 2, and there it is. You can see that point of tangency, and you can see how bad my little sketch was. Okay, so that's always a way to check your work. That's a real common problem that we'll do.